Okay, we are a minute after half, but I think we can start now. So it's great to be in Malmö again. My last visit was 10 years ago to be in Malmö, and it's great to be here again, and even nicer to be here with you all in the audience. So let's have a start. The topic today is about integrating FileMaker with DuckDB. First question to you, how many of you have ever heard of DuckDB? Please raise your hands. Oh, it's some. Great. And how many of you have worked with DuckDB or gave it a try? Okay, so I'm here today to answer your questions. We will have a look into how the integration works with FileMaker. I've prepared something to show you today with the help of Node.js. We will see how this technically works, and we have a short demo to see some interesting use cases that are possible with DuckDB, and later on we go into a special use case using DuckDB as an ETL pipeline for FileMaker data. You know what ETL means? It is extraction, transformation, load. It's from the big data guys. This is a common pattern, and we can apply it with DuckDB to FileMaker data as well. And we use it to feed dashboards, and that is a quite interesting use case. I have some samples for you today to show, and we just begin. Before I start, I like to introduce myself. My name is Marcel Mouret, French name, but German guy. I'm into FileMaker for a long time now. My career lasts for about 4 decades now, but I professionally started in developing 36 years ago with FileMaker version 2. FileMaker is the main part of my tech stack in these days, and I'm also the host of a German local FileMaker group. Last week we just had our 100th anniversary meeting, so we had a small party there. It was nice. And I'm also a speaker for FileMaker related topics. You can find me on Twitter with these 2 accounts, and it's all linked in the slides if you want to try later. So why DuckDB? We have already a database, we have FileMaker. Why do we need any other database? Some click button here. So if we look at DuckDB to understand what it is, this is a homepage of the DuckDB Foundation, and they tell us some keywords. DuckDB is a fast in-processing database system. It's simple, portable, feature-rich. I didn't heard anything about it. First time I heard this name was 2 years ago, and last year I stumbled upon a kind of article in an online newspaper, and I thought, oh, I heard about this, let's look deeper into it. And I was surprised what I was finding there. I had no idea, and I hope I can bring you some of these ideas I learned today. Because it's a hot topic in the IT world. DuckDB is a kind of jump starter. They have millions of downloads per month now because it's so well thought out piece of software with so many use cases and on so many different platforms. It's absolutely worth to get into it. I try to define what is DuckDB from what I have learned in the months before. It is RAM-based, it is in-process database, it's an OLAP tool, it's a single node engine, open source, portable, and the idea behind it is to bring the engine to where the data is. On the opposite side, what it's not a classic database like we know FileMaker or any other database engine. It's not client server, it's not data storage in the first place, it's not multi-user, it's not vendor specific, and it's not bring the data to the engine as we know it. So this raises even more questions, but we will have some answers shortly. So to define it better, the strength of DuckDB lies in it has a very small footprint. It's just a single execution piece of software that you can put in different places. It's blazingly fast. So it's one of the main advantages. It's available on all platforms, not only Mac, Windows, Linux, but also on portable devices. I think 12 different CPU compilations for different CPU architectures even. It has a very interesting feature set, which is the second big advantage beside it's so fast. And it can access online and offline data sources in multiple formats. It's used mainly for data analysis and ETL, but there are many creative use cases where it makes a lot of sense, and we will see some of this in the FileMaker world shortly. So DuckDB can load and process data. It supports CSV, Packet, JSON formats, Excel files, and many other. There are even some plugins to load other data formats. It has a tolerant parser and one even of the fastest CSV parsers in the world. They had put a lot of effort into this engine to being a good CSV parser, because it's the first problem if you want to work with some foreign data. You have to get into it, and they do a good job. They have a column optimized storage. That's something special because they do this analytics approach, and it's important to columnar storage because it's really fast and it makes some interesting things possible. You can use it to modify, filter, aggregate. They have an extended SQL set. It's standard SQL, but even extended with some specialties you would not find in any other engine, and so you can look at it as a Swiss Army knife for data. And so it could be useful as a standalone tool, but it's even more useful if you put it into some other environment. The SQL power lies in, they have some friendly SQL, so if you write some commas in the wrong place, it will even work. You can, they have some shortcuts. You can leave out some traditional techniques and make it easier. They have wildcards for column, even regex and some highly sophisticated patterns. They support nesting, unnesting of list arrays, JSON structures, and it's a really rich feature set to work with this. There are CTEs, that these are the kind of subroutines in SQL. You can define macros, subqueries, and there's a really rich function set for the typical use cases we face every day with date, with time, with strings. And if you want to go further, there are even extensions for geospatial data, for LMMs, for whatever. And it's just to show you some of the topics to understand why DuckDB is such an interesting topic. If you think of SQL power in comparison to other worlds, if we look in the FileMaker world, we have SQL as well, but you can do some things with it. Compared to standard SQL, the possibilities are even go a bit further. You can define some advanced techniques that FileMaker is not capable of with its inside SQL set. But if you think of DuckDB, it is even more than the standard SQL stack provides. It has over 600 functions. It is a bit like MBS plugin is for us in the FileMaker world, so is DuckDB in the SQL world, and they have one of the best engines for attaching to data. And if you look at speed and performance, it's even crazier. Compared to FileMaker, I will show you some use cases from real-world scenarios. SQL is sometimes more performant on data like compared to FileMaker when it comes to really huge data sets or many users. When you have 10 or 100,000 of users, you won't be so happy with the FileMaker engine. But we will mainly look into analytics. And so analytics is a place where DuckDB is really performing, and it does 10,000 to 10,000x the performance of traditional engines, and it's really amazing. And we will have a look into it, why it is even possible to do such things. They optimized for speed. This was one of the design goals from the DuckDB engine. They are RAM-based. You can write to disk if you want to, but you can anything with the data do in RAM. They are hardware optimized down to the level 1 caches of the CPU. They have done a lot of highly sophisticated engineering. They are some of the best database engineers in the world that designed this engine. They do multi-threading. If you have a modern CPU in your laptop with 16 cores, you can make use of it. They have a vectorized streaming approach so that they can process data that is larger than memory very efficiently and reliable. There's this columnar storage format that makes advantage of these aggregation functions. And they have the best-in-class query optimizer. They hired the best people in the world that wrote academic papers about how to build a database engine, and they realized it. They just said, we are not academics. We want to do something in the real world, and they all this crazy stuff they wrote for decades and some technical papers, they put it all in one engine and proved that this is possible to build a really modern engine that is really better than everything else. And you find some references in the slides at the end, where some talks of the engineers that built these engines. It's amazing. You can learn a lot of how to build modern software. Because a quote that I remember, they said all these database engines we know today are 50 years old in their foundation. And if you want to write everything from scratch and build really modern stack, there are different approaches today to make possible this highly optimized things, and we gain this advantage of a lot of speed. And there's other lot of nifty tricks they included. So how to make use of it, because we are living in FileMaker. We are not DuckDB technicians. So we need some middleware, and the approach that I would like to show you today is to use Node.js as a kind of local REST API to call DuckDB engine from FileMaker, and it's very easy to implement. We have an insert from URL, send over some JSON with our query. The Node.js part handles this over to the DuckDB engine and then gets back a result as a JSON. And this could be inserted from URL into a text field or variable. Why Node.js? Because it's low barrier, it's available on all platforms. I'm no Node.js guy. I just asked ChatGPT to do some example and was surprised how small code and how easy it is. It is easy to deploy, easy to maintain. You can run it locally or run on another machine. And if you do this REST API approach, you have a kind of microservice architecture, so you can easily integrate it in an existing environment that you might already have in your solution. There are different options. You can also include DuckDB in Python because there are ready-made modules for Node.js and Python. They're easy to integrate, just one line of code, and then DuckDB lives inside the code space of this other environment and have full access to the RAM. And this is one of the main advantages if it comes to speed and performance. To access all this data, it's already available. There's a third option, and with WebAssembly. WebAssembly is a kind of modern technology to recompile virtual code into your in a binary that lives in your browser and can run there. So you could attach this to a JavaScript inside a web viewer. It's also a possibility. But if we want to make it more flexible, the Node.js setup makes some sense. We'll see in a minute. So how to build a REST API with only a few lines of code. I was surprised how simple it is. It's some lines to require a module that is called the Express server. Express is a kind of web service that runs inside Node.js. With some simple lines, you could set it up, initialize it, and create a port where it is running. And then the second part is to include DuckDB. And DuckDB is available as a module for Node.js as well. So just one line of code to include it, another line of code to initialize a RAM-based, memory-based database instance where you can run the commands. And then you need some kind of request handler. And with this Express module, you can set it up very easy. There's just one function I defined with /query as an URL on this local service, and it gets some input from a JSON object. We pull this query out of the object, put it into DuckDB, get a response or an error message, and return it back to the caller, and that's all. So it's really simple parts. Include Express, include DuckDB, and write a request handler, and so we have a local REST API up and running. So there's a ready-made template for you. You can download this from my blog. there's a lot of documentation to understand how to get started. And afterwards, if you want to start your own experiments, you can just download this and start with a sample file. And we use the same sample file now. I explain in short how it works from the FileMaker side. It's just one simple script to get parameter. The parameter is the text of the SQL query we want to send over to DuckDB. Then we have a second parameter for the format, because I thought it would be nicer if these REST API from Node.js can provide other formats as well, so we can get text or JSON or HTML or formatted HTML. So we have this second parameter to define what we want to get back. And then we pack it together in one JSON, set up curl option to wait for timeout, hand over this data, and we have just this URL with this local address and the slash query that we defined, we saw it a minute before in this other script. And with insert from URL, we fire off this request to the local API and get back the response and store it in a variable called response, and that's it. So we have the data back inside FileMaker. Very simple setup. This is a demo file. We just jump in and have a look at it. Can show you the components here. This is our query text field, a result text field. There is another option here to get the result as HTML. There's another text field here. This is displayed in the web viewer here. And we have this pop-up menu here to define in which format we would like to get the data. And we'll have a look in the script editor as well. So the run query command, I try to make it a bit bigger as a side here. We just call the main script, and when we get back the result, we decide if we have HTML and put it into the web viewer, or if we have just a text result or JSON, we format this and put it into the result field. That's all. And here is we saw the snippets before. We get the query and the format. We reset the result to empty. Then we package two components together in another JSON data field. Here is even the option to put get queries or post queries, but it's not that interesting here. We have this curl option. Here is where we fire off the request to the URL, and we get back with insert from URL the result to response. If it's valid JSON, we make a format of the JSON to make it more readable, and then just exit the script with the result. So very simple, no complex things going on here. And we can just run a query and we get back the result. So if we select hello world, this is standard SQL, we get back a result here. We have some records here with prepared samples. We can calculate, select 1 plus 2 or 3, that's obvious. But now we come to the more interesting parts. We want to exchange data, so the first thing we want to know which kind of data we can read in or write out. And there is a folder here. The script lives inside my local web folder. I have a DuckDB REST API folder. Inside there is a data folder with EngageU. Here is some sample data. And yesterday I asked ChatGPT to provide me some random data of people with some email addresses and fancy names and company names. And so we try to read this in. We make just select from and the path of the CSV, and we get formatted JSON back. And what's happening here? We haven't even defined a schema. We haven't defined a table. We haven't defined some fields. We just do a select on a file. And the DuckDB engine is capable to understand what we like to do, because we have .csv in the file name. DuckDB engine guesses it could be CSV format, and then runs a sniffer to read portions of the file to understand the schema, to understand the data types that are included, to identify some possible errors if the file format is not okay. And when everything is fine, we just get back a response. And so there's not even any data copied to somewhere inside our solution. We just get the result we ask for. And we can make it a bit further. We can run a query and order it, just like you know common SQL. We see an HTML here. We can even get back as text or as JSON as we saw before. I could make it more formatted here with some CSS code. So we see the country is sorted here, and here is the age sorted like we put it into the order by statement, but it still reads CSV from the file. There is no tables or fields included at this moment. So we go a bit further. Here's a more complicated select statement. We try to provide the names of the country from the shortcodes, and we want to count the number of the people and group by country. So if we run this, we got a simple aggregation and some kind of report on the CSV file without supplying any scripting, without supplying any schema in our database. Just put out a query to a file and get a result to FileMaker in the way we would like it. And so this is the first impressive step, how easy it is to make sense of any data that lives on your hard disk somewhere. And CSV is a common ground, but there are other options as well. So if we go a bit further, we can even do select star. That means we select everything, and with the concatenation here, we add a formula, and we add the formula now to create it or replace it in a table. We call the table people. The table would live inside the RAM, and we read this data again, and then we have a nice option here, very powerful command inside the DuckDB SQL dialect. It's a pivot, and you know this pivot. It's a common request that we get inside our FileMaker solutions. And what you usually do, you have to set up some extra table. You have to set up some extra GUI. Perhaps you make use of virtual list technique. You have to do some scripting to collect the data, to aggregate it, to lay out these columns. And if we have this segmented by years of 10 here, would it be even a bit more complicated to provide some kind of UI if this segmentation changes? So there's a lot to do if you want to build a solution for this in FileMaker. And now we have just a simple command. We provide a table name on which dimension we want to do the pivot, on which aggregation, the count of the age, and we group by country. So we get a nice list by country in buckets of 10 years ages, how many people of this CSV file fits into each category. And so it's quite easy to provide a lot of aggregation power with a simple command. In the next step, we take it a bit further, because we take this same pivot command from the slide before, but we copy it to an output of an Excel table, and there is an Excel driver included. You can just load a kind of plugin here. There's a spatial data plugin for geodata, and they include a driver for Excel files. So if we start this and have a look at here at the right side where the other files live, we write it out, age by country, XLSX, and if I run the query, we have this Excel file. We can open it and see we have the same pivot table in a second with the power of one simple command. And it's an interesting use case for some FileMaker business cases we face in a regular. So we can go further and even read Excel. We have another file here prepared. There's some text in it, some values, even some diacritical accents to look if the data translation between the different words really is accurate. If we run it, we get back the JSON here. We see the umlauts, the Swedish ones, the German ones, everything fine. And now you can think this further. We have a select statement. We can put some more specifics in where index equals 3, run it again, and we have this value out of this part of the Excel table. Very easy to translate the data. We can read in Excel parts of the Excel if you get some kind of reports or data from other systems in CSV or Excel file. Just put in a query with DuckDB and load the data as JSON to your FileMaker solution and make any sense out of it. So we saw we can read it, we can write it. We had local files here, but we can go further. We can, okay, this is aggregation on the Excel file, so it makes a calculation here of these values. If we compare it, we see here is the average, and we see the sum here, but we can get the values quite easy with the sum function and the average function here on this column. And so you can make any queries on an Excel file and get the result back to FileMaker. So we get a bit further, and we can even load files that live in the web somewhere. This is address from the DuckDB organization. They have some data URL here where a Packet file sits. The Packet file is indeed 300 megabytes large, and if we do a select, we would expect now to download 300 megabytes to our machine to display this result. But if I click the button, it was about a second and the result is there. Why it is possible? Because it does not load 300 megabytes of data, but it has an internal pointer to the Packet file and knows where to look up the bytes we need in the Packet file and only grab this portion of the data. Packet is a highly sophisticated format for data storage. It's on the Apache organization license, and it's worth to dive deeper in it. Because Packet is kind of a database in a file. Think of it as CSV on steroids. They have data compression, they have columnar indexes, they have all kind of tricks to select and read data, very efficient over networks, and so you get very little data transferred back and forth. And even here, we didn't copy any data. We just sent over a request and grabbed the result. And so we can do with more complicated things. Here's a CSV file. I don't know how big it is, but we make a select with some columns, and I clear this and run this again. It takes about a second, and then we have 500 rows from the sample, and it even was very quick. And we created a table here, and they provide some really interesting stuff on their blog. I copied here an example from this web page. They have a database of all Netherlands railway traffic, and this is a huge data set with gigabytes of data and some different tables, and they showed how they could build with sophisticated techniques that are only possible with DuckDB to get the top 3 busiest train stations for each summer month. So they select some data here from this Packet file living in the web. They make a select statement here over some months between 6 and 8. This is the summer months, June, July, August. And they build a kind of ranking and group this and order it by months. And if we run it, we would expect some gigabytes of data to aggregate this in this sophisticated way. It would take some time, but I click it. It just shows up some seconds that data is going forth and back, and then we have a result with a highly aggregated data on this complicated set. And it's really impressive what they can do with this engine behind the scenes. So this is accessing web data as an example. We can drive it further. I found an example to access web APIs. Web APIs normally have some credentials to authentication, and you could not just load some URL, but you have to authenticate. And they provide a mechanism to give extra HTTP headers with authorization credential here. And if you run this, this is a Stripe API. It has some customer data here for test purposes, and we can even read the API data as a JSON here with one simple request. In the next example, we go a bit further and read some 2 of the columns included in this customer. And if you look here, we send the authorization. We read a JSON. There is a special option here to read JSON, and we make an unnest of the data we get back from the API. And the unnest delivers us some kind of data structure. We could access the ID here, and we can do a calculation to convert it to a timestamp from the created field here. We limit it to 10 and run it. and what we just get back is some result from an API call in just the format we wanted to have it in our solution. So it's very powerful to make use of it. We can do this in FileMaker, of course, but FileMaker have to do all these extra steps to bring the data, filter the data, bring the data down to this kind of format we want to have it, and this is a very efficient way to access the API here in this way. So we can even go one further to see how potential it is when it comes to big data files. I have a transaction folder here there are living 15 files. This is 15 years of transactional data from a living system. We can just read them as text and get metadata out of it. So we have some functions to parse out the file name, the file size. What we did here is we read the directory and listed all the available files with a wildcard. And wildcard is interesting because it also works when we import data. We can do this to calculate the total size of these transaction files is 324 megabytes. And if you want to deal with 324 megabytes in FileMaker, you get perhaps an idea that it would take some time. And so we do we read in all these files with one single line of code because we have a wildcard here. So if we look in the transaction folder, DuckDB will read all the files at once, never mind how many are there. And so they have the same structure because I got it out of my FileMaker solution. We can provide some options here that we have a tab delimited, we have a comma as a decimal separator. In other countries it could be a point. We have a special date format here. We have an option to ignore errors if there are any, and I could define a little schema here to define which field should be interpreted in which data type. And then we create or replace a table called line items with a select on this schema I defined here. And I even make some calculations here to transform the data to have if some value is missing, I can provide a value here, and I read the year as a part of the date with a function from DuckDB. We just run it and look how fast it is. Zack, we have the result. There are, we just got the count of the rows here. It's 5.2 million rows that we read out of the CSV, and with a click of a button. It's a second, 2 seconds perhaps, and it's ready. Now we can read all this amount of data in such a short time, and this is where DuckDB is really good at. We can do some summarization perhaps. There's a simple command to get an idea of what is inside the data. So we have here all columns. We see the type of the data, the minimum, maximum value, some average values, some quantiles, a counter of the values, how many null values are inside. So if we don't know the data, we could just have a look and some approximation what we would expect. But as we know the data, we can do something more, and I just do here some aggregation of 2 columns. And if I click run, there's a result instantly, 5.2 million rows of data, and we get an instant result with a complex aggregation. And this is quite promising to dig deeper into this. So there is even an HTTP client for DuckDB. It's relatively new. I gave it a try. So we can query a web page. Don't know if it makes any sense. You see it here, we get the URL, the HTTP status, and we get the whole HTML result. And I thought, okay, let's try to make some sense out of it. I went to the speakers website from Engage. This page. We have this yellow names here, and I thought, wouldn't it be nice to have a query that read all these speakers from this web page? And I gave it a try. You see it here, we load the speakers. get the body with this HTML. We have an regex command here to parse out the body with some H3 headers and some in between here with the star is an interesting thing. And we get back the first found inside the two HTML tags here as put an unnest around it. And when we start it, it reads the web page and gives us the result with a list of speakers. So it's just a crazy example, but just to make you an idea of how many use cases are inside this toolbox. And so these are just some examples to see how to read and write data with the help of DuckDB. And now, when it comes to performance, my first try was, we just saw this with this 5.2 million lines. My first example, when I just was new to DuckDB, I had some data out of a FileMaker solution with 130,000 lines of data. I just wanted to read this in, do a calculation, and to do aggregation. And the block at the bottom, you see there's a select with all these columns and the sum or average around it. So it means the engine has to go through all the rows and all the columns and calculate some values out of it. When I did it with FileMaker native, it took about 1.3 seconds, and it's not bad. It's fast enough for this example. But if I tried it in DuckDB, it took just 40 milliseconds. So it nearly 1,000 times faster than to do it in FileMaker. And that's a very simple scenario. And to be fair, first I had to get this CSV data out of FileMaker to feed it to DuckDB. So we put a penalty on top. Exporting the data from FileMaker took about 0.9 seconds. That is a bottleneck here because FileMaker is a bit slow to write out this data. DuckDB reads it in with a few milliseconds. It's 23 times faster to read the data than FileMaker wrote it. And then we put the aggregation on top of it. And it's still faster. Even if we export the data first and then do the aggregation with DuckDB, it's still faster than FileMaker native. And so it opens up the idea that it could make a lot of sense for special use cases where you need this kind of aggregation that is costly or cumbersome to do in FileMaker to use a special tool for it. And so I did. Some months later, I stumbled upon a use case in our company. We wanted to aggregate 20 years of data to examine some trends inside the data, and it was not that easy because we have no direct correlations to the attached data from our products. It had to be calculated some statistics on it and some weights and reattached to the whole data set, and it's a really complex scenario. And I just gave you the numbers here to understand. It took me about 2 weeks to implement this aggregation in FileMaker. If you look at it, 12 tables, 86 helper functions, 10 custom functions, 56 scripts, and 1,500 script steps to make this happen and even possible. I was happy to have this because it was really an important question to answer in our business context. And some weeks later, I stumbled upon DuckDB and thought, oh, this could be a really good use case to make some sense out of DuckDB. And so I re-implemented this whole approach with DuckDB, and you can see this on the right side of the column, only 6 CSV files from FileMaker with the raw data, just one simple query. Okay, simple, it's not simple, it consists of 27 select statements, but I was able with 27 select statements with about 300 lines of code, and this is readable lines of code. You can stuff it even, compress it even further. I can do the same calculation as 1,500 script steps in FileMaker, and I don't need all these helper fields and custom functions and TOs and what else. I learned a lot in implementing this. I learned a lot about the commands from DuckDB. It was even faster to do this, but the most surprise was when it came to the time to perform this. Because in FileMaker native, it took 10 hours to calculate the result. and DuckDB made it in 4 seconds. So it's pure magic. The first time I did it, I thought, oh, there must be some kind of error. It broke down and didn't calculate the result. There must be something wrong. And I evaluated every single step and looked up the steps in between and compared the data. Everything was right and correct. And this is really amazing. And it opened up a whole new range of possibilities, because now we were able to do time slices of data. We can do nearly real-time calculations. We could slice these 20 years of data down to months resolution and see some trends and put it on some dashboards. And it's really amazing stuff. And so this was a really game changer to make use of DuckDB in this special case. And it opened up my mind to look for other use cases where this could be some solution. And you can read this on a blog post if you are interested in this special case. Even the DuckDB people read this and published this on their social media, because DuckDB is a really nice community of researchers, of data analysts, of big data people, of crazy people who use DuckDB for everything. And it's kind of like the FileMaker scene, but even a bit bigger. And you can learn interesting stuff there. And so possible use cases we saw before: you can export FileMaker data to CSV and process it with DuckDB. You can import Excel or CSV and get result as JSON. This alone could be worth it. You can build pivot tables. You can read from external data sources in the cloud and mix and process these data sources for analytics. And you can use DuckDB as an ETL interface. And that is in reality what many people do with it, because it is so fast and is so efficient on a single core. You don't need a whole cloud infrastructure with tens or hundreds of machines. You can do it just on a laptop. Even if you have big data in terabytes range, it's highly efficient. And so you can build tool pipeline to display dashboards, even in the FileMaker web viewer. And that sounds kind of interesting. So I have prepared an example from a real use case. So ETL and dashboards is, if you look at it, how it is solved in other systems, it is kind of always the same. So grab the data from somewhere, from your production systems. Our production system is FileMaker. So we build this pipeline here. We push out CSV files from FileMaker because it's cheap in kind of processing power. It goes fast. We use DuckDB first as an ETL engine to transform this data to the format that the dashboard engines will need it. And there are some very interesting tools I found. Evidence is a very interesting one. Observable, they have very sophisticated. These two first are open source. Locker Studio, perhaps you have heard of it. Google acquired it some time ago. It was called Google Data Studio in the former years. It's also a very interesting tool. We have it in some use cases in our pipeline. And how to handle this, what I've learned to provide you some best practices. When you export the CSV file from FileMaker, just take some master data, your product names, customer IDs or whatever is inside your use case, and the transactions, and only export the needed columns, because in most of the cases what you see in the dashboard is only a handful of columns that you need to aggregate and manipulate or mix it up. And so in FileMaker this is fast enough. I showed you this example with 15 or 20 years of data, and with this wildcard, you can just export the actual year. The actual year is some 100,000 records, and if you only take 5 or 6 columns out of it, it goes in under a minute. So in under a minute, you can export this CSV file from FileMaker, and if you have some tables with customer data, product data, whatever, you add it up, you have a bunch of CSV files. You can do this daily on a server or on a special machine. I've run a script every night, and in 2 or 3 minutes, I have all this CSV data living in some space on the file storage where DuckDB can access it. Then I have another machine that has this simple setup you saw before with this Node.js. I have a subdomain, a local subdomain, so I can call it from FileMaker on another machine, process this data, get back this data if I want to. We have seen we can read files over DuckDB, just select a folder and get back some files, and we can store it back in FileMaker or write it to disk or send it by email or load it up to another service. So it's very easy to integrate in FileMaker. And DuckDB is then used to prepare, to normalize the data, to extend or mix. And DuckDB has their own format, an own file format. It's highly compressed, so it's very small files. In my use case, I use a daily setup of about 2 million rows of data, and it ends up in about a gigabyte of data inside DuckDB. And it's one single file. I can copy it over to a dashboard solution I built with Evidence, and then Evidence is able to read from this single file with multiple tables in it. And so we push this data to some analytics app. It could be local, it could be cloud. There are a lot of options, and then display it in a web viewer. And so we close the circle. The data came from FileMaker, and we make this data accessible in the web viewer in the same location where the data lives. And I prepared a short demo to give you an impression. Okay, here's the screen. So this is a products file. It lives there in the solution for 25 years now, so don't mind these old style GUI here. It survived a lot of iterations and versions, and what we see here is a standard FileMaker layout, and I just added a pop-up button here, and the pop-up button, when I click it, it provides as a view of a web viewer. And if you, I hope I can zoom it in, yes, you can see it here. Here is a local host address with some URL, and the product number is part of the URL. And this is an interesting detail, because we will see in a minute how this works out. I can just push this button, something happens in the web viewer, and here I have an interactive dashboard to 1 year of sales data. And I even have some selectors here. I can filter this down to just one customer group that I'm interested in. I scroll down here to see the customer groups in detail for 365 days range of sales. I have even some bar charts here with popover and numbers, and it's some simple, rich dashboard to provide the sales guys some information they need about the products. So how is it made? I told you about Evidence, and Evidence is an interesting engine because it provides simple markdown file. So you have a file with some markdown logic here. You can put in some objects and even some simple text or whatever, some GUI. And you can put in some SQL queries. And Evidence is integrated with DuckDB, so DuckDB lives inside this Evidence solution and reads the data out of the file and provides a real-time view on your data. So I told you about this little detail here in the name of the file is a markdown file. There is an article number in brackets, and the brackets mean that Evidence provide this as an parameter, so I can read the parameter and just throw it into my SQL select statement. And so if I'm on another product, there is another product number in the URL, and the SQL select just resembles and brings up the data for another product. And I select here some data, and then I have a bar chart option, and I just put in the result, and I have some options to define how the bar chart should be shown. It's too much to show it here in a short demo, but Evidence is really powerful and really simple to set up. You can, it's open source. You can pull down the source code, run it on your machine locally, and it can also compile static websites that you can render out to some website to provide it to your customers or wherever. But it's very simple to make use of it. You just put in some markdown, some SQL query, and some chart objects that are well defined. There are some GUI selectors as well, and you're up and running in minutes and have a very powerful tool to display dashboards. So it's really worth to have a look at it. And I just showed it here as a demo to provide you with some ideas how you can integrate such a pipeline from FileMaker over DuckDB to Evidence and back in the FileMaker web viewer to have a real nice business case here. So in summary, this is just what I learned about DuckDB first in a few days, my first steps into it. Later, I spent more time, some weeks, to understand the potential and to implement some use cases. This is a nice tool for data crunching and analytics. It could be very simple data crunching, as we saw, to convert some Excel file to JSON or whatever, or even complicated reports, do some analytics with it. It goes far beyond regular SQL databases. It's easy to install, and it's relatively easy to make practical use of. And I hope it shows you some benefits if you want to dive deeper into it. So this session is meant as a door opener that you can download this REST API as a sample file. The demo file is available with all these demo queries in it. You can play around with it, make your own experiments, and just have fun. One more thing, I told you about WASM before, WebAssembly. And it's interesting because DuckDB is running in your browser. It even runs on your iPhone. So if you want to start immediately, you can just type in shell.duckdb.org, and then this window shows up on your iPhone in your browser, and you can start querying from your browser, from your iPhone, on some data set in the cloud. So it's amazing tech stuff, and I hope you have fun with it. And if you want to go deeper, I recommend to start with the DuckDB website. The founder said they built, by accident, one of the most trafficked websites in the whole Netherlands. They have hundreds of millions of downloads these days. And there's a really good documentation. You can also download the documentation locally to learn. And the documentation is a good learning starting point. There are many examples. They have a good blog. They have even own conference in January. Next year is the 6th conference of the DuckCon. There are speeches online on YouTube you can look up. The source code is available on GitHub. It's open source, and they provided a structure of a foundation that they could not board by some VC and integrated in some other product, but it's free. You can integrate it in your products. That is a promise they made. It won't cost you anything, but learn about it and use it. And there are even 3 good books, meanwhile, that describe use cases. There's a lot of stuff on YouTube, on GitHub. And if you want to know a bit more about the backgrounds, I highly recommend. There are some good interviews with Hannes Mühleisen. He's one of the founders. It's a CVI institute in the Netherlands. He's a German guy, but he's 30 years in database engineering, and he knows a lot. And he tells in his talks why they built this engine, what were their design goals and tricks to make this happen. And there's a lot to learn to build good software. And I must say, I have a track record of nearly 30 years also, and this is one of the best pieces of software I've ever seen in my whole career, because they did everything the right way, how you would do it in a normal way when you haven't got the pressure from your customers. So they are in the academic space. They had this opportunity to do this the right way, and they did it, and so dive in and be surprised. Here is some more reference about the dashboards. Evidence is a good thing because it's also open source. It's easy. It's a low barrier for entry. It's DuckDB included. So there's a lot of interference with these 2 technologies. But there are other great options to choose from. Depends a bit on your use case. Then if you have some questions about the Node.js, how to install on your machine, there are some manuals to make this happen, and it's not that hard. You can make it in some minutes to make this up and running on your machine. And even I told you about Python and this other stuff with plugin like MBS or the Bbox plugin. I will provide you a sample file for this as well. If you also have a step into the Python world in FileMaker, this is another way to do it without Node.js. So I have to say thank you that you were interested in this kind of special topic here in the FileMaker conference. And we have some time left, I think 5 minutes for Q&A. So please feel free.
Hi, Marcel. One. Okay. Yes. Okay. Hello, Marcel. Thank you for this wonderful presentation. I just want to ask something that I don't think it was perfectly clear. So, for example, if you create a database, a table on DuckDB, what would happen if the terminal session that keeps the Node.js server open, what would happen if that is killed? So, for example, you do a server restart. Would the table exist?
It depends how you set it up. It's a great question. If this is persistent, you can choose persistence and send it a file name to open a local file, and this persists, and they have the best interruption prevention in the world. They have thought out every option that could happen, that your machine crashes, the process crashes. They have some logic inside their process to protect your data, and you can put it on your machine. And so if you put it on Node.js, you can have on macOS some kind of what is it called, CTL. There's a service inside macOS you can use to spin up on the start of your machine, that it loads just in the background and it's running. I did it that way, and it runs always, and it's always reliable.
Okay, so it could be used as a proper database, for example.
Yes, you could use it, but it makes more sense in an analytical way.
Of course.
Yeah. Okay.
Thank you.
Just hand it over. Yeah.
Thanks, Marcel. Have you ever tried using either a data API or OData query to FileMaker server as a direct data source for DuckDB?
Not yet, but it would be an interesting use case. It depends on how efficient the FileMaker server is able to provide some data. If it's small data set, it could be a good way to access data API, or OData would be even better, I think. And if it's larger data sets, it makes perhaps more sense to export it first to some file. Yes, Nicholas.
Thank you, Marcel. One single question. If you want to install DuckDB, do you think it's a good idea to make it the same server than the FileMaker? It doesn't take too much part of the system, or do you put another machine for the DuckDB?
We have every option you can think of.
But it doesn't require too much.
It's very small. Yes,
it's very small. No,
it's very small. And if you process large data, it makes use of all your RAM and all your CPU power you have. But you can limit this even. That you say, okay, I only give you 8 cores and such amount of gigabytes of my RAM. If you have other processes running in the background, but it depends on the use case. You have every option to put this engine in.
Okay. Thank you. It runs under Linux also, no?
Also, every platform is supported.
Perfect.
Every
Thank you.
CPU. Just give it to behind you. Thank you.
Thanks a million, Marcel. Just thinking about other options, could you run this through Node.js if you've Node-RED? Sorry, if you've already got a server set up with that. Would that be
yes, of course, because
I just looked and found there's a DuckDB connector for it. But
there are plenty of connectors, and there's an ecosystem of community connectors. They're built in, some that are installed with the main engine, but you can load community extensions, and there are a lot of it to connect to some data lake architecture or to some special use case. There are use cases for Python and for R for analytics and really good stuff. And sometimes the DuckDB engine is even faster to support the calculation as the surrounding engine itself, because they have a better architecture. And so there's a lot of things happen. They have even a kind of template to bring your own plugin, and this is an interesting option perhaps for us in the FileMaker space to deploy a kind of plugin that talks directly to the data engine of FileMaker, and that we have not to export and import the data before. So it's perhaps possible to exploit this further and provide some plugin for this architecture.
OData.
Any other questions? Yes. Thank you. Douglas.
It's not really a question. There's I think I saw something that the company created an environment where you can use DuckDB and AI. So basically they use a local LMM.
Yes.
They create everything together, and they're doing fine tuning really quickly to be able to create the LLMs based on this stuff. So because it's really powerful for that.
Yeah.
You just need fast machines. That's the thing. So.
Of course, it's a good point, and they did several things in this space. They have a command to select an answer from an LMM. So you can provide a prompt with some parameters as an SQL query and get back the result from an LMM. That there are some interesting use cases to clean up table data or whatever. And the other thing is they have support for some semantic data layer for providing these, how you call it, these embeddings. There are embedding calculations and functions to make sense of calculations. There's a lot of stuff inside it, yes. So I think the time is over now. I thank you a lot for coming here today, and have a look at the website. Yeah.